Hey guys, hope everybody is cool. So guys, hope everybody can hear me. Hope everybody's having a great morning. My name is Danny. I'm gonna be doing your intro to neural networks workshop today. We are actually not gonna be using Anaconda, unfortunately, but you're going to be using Jupyter notebooks anyway, just and specifically the IPYNB files associated with Jupyter notebooks, but you're going to be using them in a website called Google Colab. We will be seeing that in a second. So, what's up, Mo? Let's see. What's up, Kingsley? I remember you. Nick. Let's get it, guys. Good morning, guys. I'm gonna start at like 9:05 just to give people time to keep on streaming on in, and we can get started. What's up, Yusuf? I missed you already, bro.
Bro, good morning.
Buenos dias.
I'm so tired.
Bro, me too, Papa. Don't worry, me too. That's funny.
Um, so we're using again my anaconda don't
Oh.
my ana-
The plan was so like I was thinking of using Anaconda, but we're just gonna use Google Colabs instead because I found
Okay,
a better like example collab to use for like
okay,
practical purposes. So,
awesome.
yeah. As much as I would like to just develop my own collab, that would take me too long. So I just got a good one from Google's training website. So research website, sorry. So it should be fun. We're going to be using Google Colab. So for those of you that don't know, Google Colab is plainly a website. Well, sorry, it's a tool offered by Google that allows you to run IPYNB files, which is the file type generated for Python Jupyter notebooks. Okay, it lets you run these type of files and other types of files as well. But the point is, you can use you can use Google's computation instead of your own local machines computation for running these programs. And when you're doing stuff like deep learning, where it's pretty intense on hardware, using Google's resources is probably a better idea unless you happen to have an RTX 2070 like I do, because I'm a cool kid, right? Or a 370 or whatever. But yeah, usually you would want a more hardcore GPU for deep learning. No 3090. Sorry, bro. I'm not that rich. I'm not. My blood's not that. My blood's not that rich, bro. But yeah, so Google Colab it is because all of you guys can run that even if you have I don't know, a laptop from 2010, which hopefully you don't have because that's 11 years now. So yeah. All right, let's see. Yeah, Richard, that's pretty much me. So we'll get started pretty soon. Yeah. All right.
Okay, there. I don't know if you answered this question already, but they're asking what's the difference between neural and 3PD, whatever it is called.
3PD. I am not sure what you could be referring to. So okay. A neural network itself is just plainly wait, so GPT-3? Is that what you meant? Well, whatever. So well, we're gonna get into neural networks, so I'm not really understanding the question. If you could rephrase it, I'll try to answer your rephrased question.
Yeah, so GPT-3, he meant GPT-3.
You meant GPT-3? Okay. So GPT-3, which right here. GPT-3 is essentially, well, okay, it was supposed to be this kind of open sourced API that uses like it's pretty much this incredible like open it was supposed to be open source framework where you could use this high powered API that just kind of like automatically has these really powerful deep learning networks and stuff to apply to like your project, right? So it's specifically more for natural language processing. So for example, let's say you're given you give GPT-3 some text, it would be able to return for you a crazy amount of things. Okay, so for example, I'm trying to think, I believe they trained GPT-3 on a crap ton of text analysis, so a crap ton of texts on like Twitter and over the internet in general. And an example was that I believe there was like this completely generated essay created by GPT-3. And like, so if you tried reading that essay, it was like extremely close to human language. Like you would barely be able to tell like that a non-human wrote it. So actually, let me look up that example real quick. But yeah,
Yeah,
GPT-3 is one of the cooler things that came out recently for AI.
yeah. At once, I was at a hackathon that it was sponsored by OpenAI, and there was an OpenAI person talking about GPT-3, and I saw it live. So it's pretty much like they first of all they built, I believe it was the fifth fastest supercomputer in the world. It was kind of like they built a really good supercomputer, and then they ranked it, and it was apparently like the fifth, and they said like, okay, this is good enough. Let's give it like just a lot of data that we find on the internet. Like we're literally gonna feed it with whatever we find on the internet,
Mhm.
and they built a neural network, and they trained the network with that data, with whatever data they found on the internet, and they let it, train for a couple of months, and then they started to. The purpose of the project was to literally see, okay, what happens if we give it so much data, and we actually don't know what's going to be the outcome of this, and it performs well, better than expected. And the thing with GPT-3 is that um, they sometimes they are still figuring out things that GPT-3 can do. So it's more kind of like it was more kind of like an experiment rather than a service that they wanted to provide. But you can ask GPT-3 like different things, and will answer you like a regular person. Like, oh, what are the best Dark Knights? Christopher Nolan. What is the best Christopher Nolan Dark Knight movie? And it will pop up like the poster and everything, and he will tell you like Christian Bale. It will tell you like Christian Bale, whatever. Like it will literally say lots of things. It's really
Mhm. Exactly right. There's also so like another thing for that GPT-3 is a really cool example of like really hardcore natural language processing happening right now in the deep learning world. Another one is I believe AlphaFold. So AlphaFold is pretty much this it's pretty much this software that it was created by DeepMind, which I believe is Google and which I believe is like a Google offshoot. So it was like Google engineers that created DeepMind, or it was just straight up Google. I forget. But basically, they created this software that is basically so. If you guys know, okay, so proteins in terms of biology are extremely important for carrying out cellular functions, right? You need proteins in order to, proteins are just essential for the natural processes of the body, right? They're involved in pretty much like every single minute detail of biology and chemistry, right? And sorry, biochemistry. So if you can figure out exactly how proteins fold, you can figure out many of the minute details of how these processes occur in a very detailed way. And you can create medicine with that. You can create medications, a bunch of stuff. Like it's extremely important to understand how protein folds, right? But there's so many ways that they can fold, a normal human just can't do it. And so algorithms have been trying to be developed to kind of like predict new um, ways that proteins can fold to analyze to see if they actually do fold that way in the body, right? And DeepMind has managed to do that with their AlphaFold software. It's kind of crazy. So if you guys want to look into that, that's like as far as I remember, that's the most recent like huge cutting edge thing happening right now.
Yeah. Oh, Kingsley's asking, but is neural network, is that a framework? It's not a framework.
Neural networks are not a framework.
A
Neural
neural network,
all
yeah,
right.
go ahead. You're the presenter. Go
Yeah,
ahead.
we're gonna get into that. So I'll just answer. Just trust me. Your question will be answered. So let's just get started then. All right. So let me start screen sharing. Mm-mm-mm. By the way, the deep left on bar, whoever posted that was pretty cool too. That's a really cool, probably like a really cool example of what's going on right now with that stuff. So cool. All right. Let me know, guys, if you can see my PowerPoint, por favor. We. Everything good? All right. Intro to neural networks. Let's do this. Just make sure. Great. All right. Ooh, that's fine. Let's do this. So, connect with me I'm on LinkedIn. Yusuf is going to drop his LinkedIn as well for those of you that haven't already, so we can keep communicating. I'm also on the Discord, naturally. For ShellHacks, I'm actually also participating with you guys. Although, don't get me wrong, I don't expect to do anything crazy. Like, trust me, I'm kind of on the same boat as you guys. I still have so much crap to learn, right? Every single time I go to ShellHacks, I want to cry because the stress just surmounts me with how much new stuff I have to learn. But it's a great feeling anyway, right? That's why we're all here. It's fun. Let's get started. I'm gonna get started with some basic AI stuff first because I'm obviously assuming some of you guys don't even know what machine learning even means, and much less deep learning. So basically, you can define artificial intelligence as machines that act intelligently. More specifically, a better definition would probably be machines that can reason, right? That are rational, specifically machines that are rational, right? This is not age. So we're talking specifically AI. We're not talking AGI, which is like its own subset, right? AGI is more a general, it literally means artificial general intelligence. You're talking more Terminator, you're talking Skynet, you're talking, I guess, the thing from the Matrix, whatever that was, right? I don't even know what that was. Yeah, so AGI is more generally like something extremely generally intelligent that can, I guess, perform as many diverse functions as like a human can, in terms of like I can compute stuff, but I can also understand like pretty much anything that's given to me with enough information, right? Like it's not just this specific thing. I can understand almost anything, right? Just like you guys can. Machine learning and deep learning are basically in well, that's this. Okay, so this I actually wrote kind of a while ago, so I'm not gonna lie, that's definitely an oversimplification. Machine learning and deep learning are computer science with statistics, with linear algebra, with Bayesian probability, with a whole bunch of other. It's a lot of math stuff, right? But yeah, so let's continue. So real quick, there's artificial intelligence is the umbrella term. All right. The overall kind of objective, I guess, of creating something that's intelligent, right? Machine learning is specifically algorithms. Any algorithm that is, I believe it's soft coded over hard coded. So, for example, if you make a program, let's say you make a calculator, right? If you give the calculator, if you have to specifically tell the calculator a plus b is equal to 2, for example, right? Or you have to assign a is equal to 2, b is equal to 3, and you add them. That is hard-coded, right? You are specifically telling the machine, this is this means this, and this is the outcome that is expected, right? Machine learning is a little bit different. So with machine learning, you still have inputs and you have expected outputs, right? So I want you to be able to do this. The way you reach from input to output is more the algorithm's I guess like purpose, right? The algorithm's purpose is to determine, hey, what is the path I should use to be able to go from input to the output we want. Does that make so? I'll explain that a little bit more. So it might be a little bit confusing, but I'll explain that a little bit more in a second. I'll send you guys this link in a bit. So what is deep learning, right? Deep learning is another subsection, specifically within machine learning. So I'll just go back here real quick. Artificial neural networks are used on vast amounts of data, okay, in order to, again, go from that input to that output. It's specifically using neurons, as we'll see right here, right? Okay. So these, so really, this is not, there isn't really an input layer here just yet. There's like more, these are the hidden nodes. Go over that in a bit. So basically you have your input node, okay? This could be any input that you want. Generally, you want it to be something that has extractable features. So let's say you have a cat, right? Let's say you have an image of a cat, right? Then you're gonna want, and let's say you want to determine if it's a cat or a dog. You want the output to be like, oh, this is 98% chance of being a cat, right? Then you're gonna want to get that image of the cat as the input. It is processed through hidden nodes in your network, okay? These nodes, okay, process the image into its base features, like, okay, this is an ear, as an example. This is an ear, this is the color of the fur, whatever. And then using those determinations, and what you want as output, it will determine, hey, so I'm getting either close, and specifically based on this thing called a loss function, which I'll talk about a little bit more later. Am I getting closer to what he's expecting or farther away? That's where training comes in. Okay. So yeah, specifically neural networks are based off the human brain neurons, right? So that's where the idea comes from generally, right? So the philosophical implication was basically like, when first thinking about artificial intelligence, we kind of had this breadth over depth approach. We were like, okay, how do we even create something intelligent, right? And after a lot of years around the 60s to the 70s, right, we were like, okay, but like, how are we going to create an intelligence when we don't even really understand how our own intelligence works, how our neurons, how our own brain works, right? So really the best first step would be trying to emulate our own brains, right? And so the closest, the most atomized thing we can get from that was the smallest part that we could get from that realistically to apply was neurons, right? Yeah, so that's just a little bit of history. We'll go over a little bit more history later. You have your input, okay? You have your input layer. You have your parameters. So specifically, you have your okay. So I'm gonna make a very clear determination later between hyperparameters and model parameters. We'll talk about that a little bit later. And lastly, your final output should be something from 0 to 1, specifically because it's probably gonna be because, like I said, it's gonna be a determination, right? Usually, with like recurrent neural networks, or well, most neural networks, you're gonna want to determine, hey, this is a cat, this is a dog. So like if it's handwriting, for example, this is the letter T, this is the letter, or this is the number 1, etc. Right? You want a determination. And so if it's 0 to 1, it's gonna be probability based, right? 98% probability that it is a cat, for example. So let me see. Anybody have any questions so far? Anything at all? I'm just gonna slow down real quick because then I'm talking pretty fast. Classification, correct. So if you are determining between hey, is the based on the is the input that I'm giving you this, or this, classification. That's kind of how you can think of it. Okay, so today's example is gonna use classification, so you'll see more about that. Cool. I'm gonna go ahead and continue then. Okay. Again, there are lots of neurons in our brain. Threshold logic is kind of one of the original ideas for deep learning. It's the idea, so if you guys have taken statistics, you'll know that continuous data, okay, is something that you can kind of determine with almost infinitesimal precision, right? So let's say you have, okay, here, hold on. And discrete, so that something with infinitesimal precision, okay, and when you have something that's discrete, it's the way we can kind of think of it is like if it's something that can be measured with 0.034578 kind of number, it's continuous. If it's something that can be determined with 0, 1, 2, or 3, so for example, I don't know, discrete would be like, okay, is this pants, or is this a shirt, is this blah, right? Is this a water bottle? Is this a laptop, right? So it's a very specific, in the case of classification, a very specific determination, right? That's discrete. So guys, a ruler. Does a ruler give discrete information or continuous information? Ooh, be careful. Be careful. Okay, so unless you guys know more than me, it should be continuous, right? So when you have something like a ruler, you can really more like a computation. So like okay, my eyes can only go up to like, I don't know, like 10.5, for example, right? The object, okay, fair enough. The object is discrete. The object of the ruler is discrete. Sorry, I meant more specifically the measurements. The measurements of a ruler is continuous. That's a very fair point. You guys got me. That's exactly right. The object is discrete. So if I have this ruler versus this other ruler, right? This isn't a ruler, but whatever. This determination is discrete. But the actual measurements on the ruler, so determining, hey, 10.2, 3.2, whatever, that is continuous. Long but infinite precision in measuring tool. That's exactly right, Alex. Cool. Okay, I should have clarified. Good point, guys. Just checking if you're awake. Let's see. I'm barely awake. So next we have heavy on learning, right? So this combined with threshold logic is really where the idea of neurons comes from. So it's based on neural plasticity. Okay, neural plasticity is this really important concept in neuroscience. Basically, so human beings, specifically from the ages of 0 to 25, so when you're born to the age of around 25, humans have extremely high neuroplasticity. Okay, in other words, incorporating new information is much easier for your brain than when you're over 25. Okay, when you're over 25, you're 26, 27. This is a general rule, not always exact, right? Not a law. When you're over 25, you're gonna need to be in more specific conditions in order to really make your brain go through neuroplasticity. Okay, neuroplasticity is like a general way that neurons collect new information and then finally hold them for you to properly understand. So cells, as the quote goes, cells that fire together wire together. All right. So if you guys want to look more into it, it's a really interesting concept. If you specifically want to engage it when you're, so let's say you're currently over the age of 25, if you really want to engage neuroplasticity for learning really hard information, then you're going to want to do something called deep learning. You guys can look into that on your own time, but it's something that I'm really an advocate of, deep learning. I'm 21 and I employ the hell out of it, right? Super useful for me. All right, so let's look at a cool example. We have recurrent neural networks, we have convolutional neural networks, we have, in this case, I'm showing you guys an example of a generative adversarial network, okay? So this is a really cool example. I like using this example pretty often. Some of you guys might have already seen this one. So you have a generator network and a discriminator network. So you have two neural networks, right? The discriminate, so you're gonna have a generator network, okay? This one will actually, sorry, I should actually start with the reverse example. You have a discriminator network, all right, which is kind of like a more example, a classical classification example, right? So discriminator network is it'll look at images, okay, at like faces, for example. You can look at images of faces and say, hey, this is a face, this is a face, this is a face. You want to train that one first with a training set, which we're going to go over a little bit later, the process of the overall process and hierarchy of machine learning and deep learning, okay? You want to first train something to be able to determine, hey, this is a face, okay? Then you're going to have a generator network, something that actually creates fake faces, okay? So they're both separate networks, okay? When you have a generative adversarial network, you combine these networks, okay? You're saying this generator, which generates faces, okay, is going to send its outputs to a discriminator network. And that's going to be the input for the discriminator network saying, hey, is this a face? The discriminator should be good before the generator is good, right? Because it's important that you're able to determine what's a face versus not a face, right? Because then, obviously, the generator is going to be bad at like producing faces at first, right? The discriminator is going to be like, hey, this is not a face, okay? That is going to be included into the loss function for, well, the overall like weights in the loss function for the generator, okay? So it's going to be like, hey, the discriminator was able to tell that my face was fake. I have to change stuff, okay? Stuff changes. The nodes specifically and stuff going on in the hidden network in the model, the model parameters are going to be what change, okay? Because it's like, oh, it detected my face. I have to get better, okay? And so it's going to try again. It's going to send that information again to the discriminator. Hey, this is still a fake face. Dang it, I have to change. This is still a fake face. Dang it, I have to change, okay? And with enough time and enough adversary, because it's adversarial, right? Because one's like almost fighting with the other, right? So eventually, it's going to produce a really good face, and the discriminator is going to be like, that's a face. The generative adversarial is like, excuse me? You actually believe me? That's crazy. But you can also even tell the discriminator, hey, that was actually a fake face. Oh, crap, I have to get better. You see, so with this, they will both literally piggyback off each other, getting just better and better and better and better. Okay, generator creates fake data, discriminator detects fake data, creating competition. Cool. So let's look at this example real quick.
Oh, Jorge Avila is asking real quick, how would you train the discriminator network in this case?
So generally in this case, you're gonna want to actually have like a more classic, I guess, classical classification network. Okay, you're just gonna want some. So straight up, you would want to have a normal. Okay, so we're gonna look at an example of a classification in today's workshop of a classification using recurrent neural networks. Okay, and basically that'll be enough for the purpose of our workshop. That'll be enough because with a certain degree of accuracy, it'll be able to say, hey, this is like a flower, for example, right? You want to have that built first, kind of trained the normal way, and then if you are introducing a generative or a generator network, right, one that generates fake faces, you're going to want to add a couple of hyperparameters and I guess like communications between the networks to determine when one wins, you have to feed that information to the other one so that it knows to learn. Did that make sense? Cool. I'm trying to give like a very high it did? Okay, awesome, great. I'm trying, no problem, Jorge. I'm trying to give as high level of an explanation as I can because this stuff is hard. Okay, even for me, like I'm still learning, right? So where was I? There you are. So over here, right, this person does not exist.com. Super cool website. I'll drop the link for you guys right now. None of these faces exist. It's kind of crazy, right? So you have esta viejita, la pobre, está triste, estás cansada, whatever. And now you have somebody who's super happy, right? It's kind of crazy the accuracy that you have with these faces, right? Like if you put this on an Instagram profile picture, who's going to say that's fake? Nobody, right? I love this website. It's so incredible. This technology is incredible. Sometimes you are going to have bad examples. Okay. That's perfectly normal when you're training with a huge amount of outputs and inputs. Okay. So in this example, it's a little, I don't know if you guys noticed, it's a little blurrier than the last example. Okay. So let me see if I can find a really crazy example. Sometimes you can have something crazy going on with these images. So for example, like I've had one time where I've reloaded the page and like this entire like top part of like basically the hair just looked like some spaghettified like Cthulhu level like horror like crap. Like it was like Medusa, it was like Cthulhu was on top of her head. It was crazy, like Lovecraft stuff, right? Realism's too real. Yeah. On males makes it look weird. Yeah, exactly. Facial hair is especially difficult, I believe, because it's such a like a small feature, right? So it's definitely harder to get right. Cool. All right. So, what technologies are we gonna use? So, some technologies that you can use for deep learning and machine learning in general: TensorFlow, Keras, Pytorch, Scikit-Learn. Cool. So we're gonna go over these now. So, well, before we even get into those, we have Python. That's what we're gonna be programming in. I hope you guys went to my Python intro workshop yesterday. I hope you guys got some cool information from that because that's what we're gonna be applying today a little bit of. Yeah, just read the slide. I'm gonna give you guys like 5 more seconds to read over it. 5.
Oh wait, can you
Yep.
go back to they're asking if you could go back 1 second to the last slide.
This one?
I think so. Is that yes.
Yeah. I agree, Dylan. That's the best part about it, right? Because when you're working with really hard statistical and math-based stuff like machine learning and deep learning, it's important. It's almost fundamental to have an easy program to code in. If you do you can do this in stuff like Java, but if you do it in Java, your brain is just going to be so overloaded with all the extra complexities that are kind of unnecessary, right? Like, sure, it might be faster, but at the cost of you developing it so much slower, it's not worth it. Would doing C++ really help the training times? I think I pretty much just answered that question, right? So yeah, so theoretically it would, yes. But let's put it this way. The very creator of I believe it was the creator of C, or the creator of the so I believe it was the creator of C. The very creator of C, when he saw Python, okay, he's seen examples. He's like, I saw this in a podcast episode. He himself said, like, oh, I have seen so many examples of like Python code running like the same thing that a C program would do, right? So it's just a Python implementation of the same thing running faster because so much of the high level things were abstracted so simply that the C program, even though like C is obviously faster, there were so many small details that were implemented in a more efficient way in Python, even if it is slower, that the overall program, which was huge, ended up running faster. Okay, so when you have really high level abstraction like Python, the benefit is you can just develop things faster and easier. And when you're looking at really huge programs, softwares, whatever, that ends up being time saved in like even runtime, right? Because you end up avoiding details that you might not have even needed in an implementation like C. I hope that made sense. So, Python is good for big data sets. Yeah, pretty much as well. Like number go really efficiently. Absolutely. I believe there's even like a Python, like I believe it's called like PyC or something. It's basically like Python, but like much closer to C. Like it runs as efficiently as C. I believe, like somebody can correct me on that, but I believe there's a whole like version of Python that works that way. For those of you interested. So let's see. All right, cool. Google's baby TensorFlow. This is Google's open source machine learning library. Contains much of the difficult algorithms and much of the heavy lifting. You still have to understand a little bit of. So okay, I used to have this mentality that you didn't really need to understand the algorithms and the maths involved with AI. You do. You should have a very at least foundational understanding, or you're just not gonna understand what the hell's going on. Like with Python, for example, you might be able to understand sure that a plus b, because a is defined as 3 and b is defined as 6, a plus b is 9, right? That's simple. You don't need to necessarily understand exactly how Python works, and you don't really need to understand exactly how TensorFlow works. But I would say understanding how the algorithms work is important, because you need to understand what you're outputting, what you're inputting, and how the algorithm affects both. Okay. On top of TensorFlow, we have Keras. Keras is just a high-level API/interface for TensorFlow. It makes developing like stuff like deep neural networks much faster and much more efficient. Okay, in general, it was created by this guy called Francois Chollet. I love that guy. He's currently I believe he's like currently the lead developer. Yeah, he created. As far as I remember, he created Keras, right? Francois Chollet. He's awesome. He's a developer at Google. Obviously, they developed Keras. He's a extremely smart guy. He has this really good book called, I believe it's called Python for Deep Learning, or Deep Learning with Python. I believe it's Deep Learning with Python. Great book. I read a bit of it. It's really great because it has so like the first chapter is like literally just like a lot of the math basis you need, and then he actually goes into the deep learning stuff. Yeah, really smart guy, and Keras is a great tool to help accelerate the development of these deep neural networks. Okay, so Pytorch is kind of the competition developed by Facebook. So I have had more experience developing stuff in Pytorch. I happen to like Pytorch. So overall, scientists. So like I guess kind of the general thing is TensorFlow is better for immediately developing software. So it's better for immediately developing applications. Okay. TensorFlow is easier for deployments, and it's just easier for deployment of applications, right? Pytorch is a little bit better for like scientific applications, and it's a more encompassing, I don't know if that's the right way to describe it, but like a more encompassing framework than TensorFlow. Okay. It's great. So if you guys want to try TensorFlow or Pytorch, both I would say are pretty good to go with. Naturally, if you are trying to use artificial intelligence for more software, so like let's say you're a software engineer who just wants to apply machine learning, TensorFlow might be the better approach. So a great library is Scikit-Learn. This is more machine learning, a little bit less deep learning, but it's still fantastic. It's built on NumPy, SciPy, Matplotlib. I forgot the name of the guy who developed these, but he's obviously a really smart guy. NumPy, SciPy, and Matplotlib. They are really good for a lot of the mathematical stuff. So NumPy is more for the linear algebra side of stuff. SciPy is more for scientific functions, and Matplotlib is more for visualization of your data. Okay. Yeah, so NumPy for matrices, vectors, linear algebra integration, as well as more scientific integrations than NumPy. And yeah, cool. Let me go for questions real quick. I'm sure there's a couple. Let's see. Good for high-level stuff, and it's used for research more heavily, also more Pythonic. Yeah, it is more Pythonic. Absolutely. Cool. Everybody seems to be on board. All right. Cool. So when you have, so look, there's model parameters and there's hyperparameters, okay? When you have you have your input layer, your hidden layer, and your output layer, okay? Hyperparameters are things actually affecting the meta of your neural network. So in other words, a hyperparameter could be the amount of layers, the amount of hidden layers in your network, right? It can be the what actually so it could be like what actually affects the loss function. In other words, like, am I getting closer to my objective, right? Hyperparameter tuning is extremely important for making sure that your model is not overfitted. Okay, that's more a statistical thing. You don't want your model to be overfitted. So, for example, if you train your data, let's say you train your data, when you're creating a machine learning project, okay, you have a couple steps that are very important, okay? First, you have the data, okay? You want to either acquire the data or just have the data available from some other source, okay? You want to pre-process that data, okay? A deep learning model is not just going to inherently understand, hey, this is an image. No, like you can't, it's not going to understand, oh, this is an image, let me just process it. No, you have to boil down that image into zeros and ones, okay? That's kind of the pre-processing step of the data, okay? Once you have pre-processed that data, you input it into, like, let's say a recurrent neural network, right? Through the input layer, then you have it processed through the neurons, okay? And then finally, you have your final output for whatever you want, okay? But the point is, the data pre-processing step is extremely important. And hyperparameters heavily affect the output of your network, okay? The hyperparameter tuning is more of the effort in the soft coding side of things than the hard coding. Hard coding, there is no hyperparameter tuning. It's just parameters. Okay. The model parameters are learned by your model, okay, during training to optimize a loss function. So in other words, when you have a neural network, it is the model itself that decides, oh, this is the best thing for determining if this is a cat. So the way the ear looks, the color of the pelts, whatever, that stuff is inherently decided by the model itself. You don't decide that. The model decides that. That's why it's not hard-coded stuff. Okay, it's soft-coded. I hope that made sense to everybody. Let's finally get to our Google Code Lab. Let me look for questions. Because then neural nets are a black box if the weights are numeric. So why do people say that neural nets are a black box? So the reason that neural nets are a black box is because a lot of times you don't really, it's not, so okay, when you have, okay, so in the case of a neural network, you might have like a crap ton, like 50 layers, right? If you really want to go crazy. Typically it's not that many, but you want to have a crap ton of layers, okay? The reason it's a black box is because sometimes if you have a really complex neural network, it's not readily determinable if it's not readily determinable what the model is using as features to decide hey, this is a cat versus this is a dog. It's not inherently easy to determine this is what the model's using to assume this being this. Okay, so the weights don't necessarily give you that information. That's the thing. Hyperparameter, a lot of stuff is considered when you pre-process your data. Also, hyperparameters include the structure of a model, i.e., how many layers of a specific type of it. So, for example, back to what Austin was asking. So that's actually kind of a problem we have in the artificial intelligence community, is not being able to determine exactly what our models are, how our models are even truly thinking, right? So we can control, like, we want you to get this input and this is the expected output, learn, right? We don't understand, it might get so complex that we don't exactly understand how it's learning. And that's kind of a problem. That's why we have this black box problem. So you guys can look into that further. Basically, the idea is you have this input, you have this black box of stuff happening inside that you really don't understand, and then you have the output you want. Because it's a black box and it gives you the output you want, you don't necessarily care how it does what it does. But that can be a problem because, well, if you get into like Terminator level stuff, you should, to a certain degree, understand how it's learning so it doesn't learn extremely wrong things. That makes sense from a philosophical standpoint, but that's higher level. Okay. I need to optimize error and cost functions to minimize the error. That's exactly right. So to avoid overfeeding your neural network, okay, so to avoid overfitting and overfeeding, as you put it, you want to have your trade. So when you input data, you want to have a trading data set. Okay, so if you let's say you have out of 100 images of total, let's say you have a total of 100 images of pets. Okay, you want to have 30 of them be training. Okay, let's say 30 of them be training. You want to have 40. So, okay, if you want to have 30 of them be training, you want to have 60 of them being actual normal processing. Okay, so with the training data, you want to, sometimes you want to have them be labeled. Okay, members of the data from the training part, but it doesn't share as well with other data. That's exactly right. So it understands really well what's going on with your training data, right? But because you trained it so much on the training data, it isn't actually able to generalize outside that training data, right? So if you give it too many cats, for example, instead of dogs in the training data, right? And you train it too many times, if you give it dogs, it's going to start as like a normal, like for new data, new fresh data, you give it dogs, it might actually be incorrect because you trained it too much on the cats. That's like a very basic example, right? Cool. So yeah, very important to have these divisions, right? You want good training data. You want labeled, usually it's labeled data so that you can tell the model, hey, so you guessed that this cat was a dog. You were wrong, right? Oh, I need to adapt. Oh, I need to adapt. Oh, I need to adapt. Okay. Appreciate it, Samara. Thank you. Cool. So let's get into it. I'm gonna drop the link now. And please remind me, guys, by the way, that at the very end, I have this last slide with some really cool resources for you guys that I'll be sharing later. It's like to further your own learning. Because if you guys are in CS like I am, you know that you need to learn this crap on your own as much as you wanna. As much as I wish I could teach you everything myself, you gotta learn most of it on your own. So let me see. There you are. Yeah, so this is gonna open up Google's classification stuff, which is what we're gonna be using. Let me run this stuff real quick. All right. So this is kind of this is written by the TensorFlow authors. It kind of used as a introductory to classification and to recurrent neural networks in general. This uses Keras. Okay, this uses Keras and TensorFlow. If you use Keras, you must use TensorFlow. It's built on top of TensorFlow, right? Yeah. So let's get this set up. So again, we're going to go over the basic machine learning workflows. Examine and understand your data, right? Pre-process that data, right? So build an input pipeline. That's kind of the pre-processing step, right? You want to make sure that your model understands exactly the information you're feeding it in the way you want it to understand it, right? So for example, I don't know if you guys know, so there's this guy called Andrew Ng. He's like one of the greatest just AI guys, if you want to call him that. He's fantastic. I believe he works at so he was the founder of Coursera. He has one of the best online free courses for learning machine learning. So if you look up Andrew Ng Coursera, it's really good. I started it. I didn't finish it, but I did go through a good amount of it. It's really, really good. Teaches you some basic algorithms and stuff. It's fantastic. Andrew Ng argues that we have gotten to a point where we focus so much on the models instead of properly organizing and having good data, as it's called, that we're straggling behind because we don't focus enough on the data, on having good data and having well organized and properly pre-processed data, right? So yeah, really important to have good data. Build the model, train the model, and obviously test the model, right? Improve the model and repeat. So for those of you who know Python already, for those of you who don't know Python, we can go over this real quick. These are just imports. You're just importing packages for yourself to use. In this case, it's just import like this for Google Colab because these packages and stuff aren't on your native machine. You can just import it without having to install anything necessarily. You just have to run these blocks of code, right? So in this case, well, I believe I'm gonna run all real quick. So here we're just importing, right? Importing NumPy because we need it, TensorFlow, Matplotlib, importing Keras, naturally layers, cool. And specifically, we're importing a sequential, which is basically recurrent neural network, right? So we're working with a recurrent neural network here, okay, guys? So we're gonna use 3,700 photos of flowers with 5 categories, okay? So are these categories discrete or continuous? Very nice, very nice, very nice, very nice, very nice, very nice. That's exactly right, guys. The category of these things, if you have to say category, if it's something that's categorical, it is discrete. When it's actually fed to the model, some of it may become continuous, but okay, in general, you are turning in this case discrete information into continuous and then pushing it out as discrete again for the output that you want. Also, like, oh, this is a flower, boom, right? If it's probability, well, that gets a little bit different. So let's see. Cool. All right. We're gonna import just the path to the images. Okay. So this is part of the input pipeline. I don't know why that happened. This is just part of the input pipeline, right, for our model. Let's see. Where was I? Cool. So here we have a copy of the data set, blah, blah, blah. And here are some example roses. Cool. Real quick, I'm going to go over Jupyter Notebooks real quick for anybody that wasn't here for my workshop yesterday. This is all Python. Okay. But we're using this thing called Jupyter. Really, it's an IPYNB file, which is, how is it again, Yusuf? Interactive Python file, whatever.
Interactive Python notebook.
Interactive Python notebook, thank you. Interactive Python notebook. So, in other words, the main difference between this and let's say something like PyCharm or another IDE is that plainly it's just going to run blocks of code and just those blocks of code as you specify them. So for example, if we were to run just this block of code, we would just import stuff. That's it. None of this other stuff would happen, right? So it's really important for making sure that the steps you're following here, literally, are properly done, right? So for example, you want to make sure that you actually have the correct access to these roses, to this rose images, right? So let's open, right? And we know that our pathing is correct. as an example, right? So we know that the data is actually there and that it is properly outputted as what we expect, right? Cool. Tulips, cool stuff, right? Very cute image. I believe it's like Netherlands that they have like a ton of these, right? Super cool stuff. Keras pre-processing, right? So this is just pre-processing some of the data. So first we have to create the data set, right? We want the batch size, we want the height of the image and the width of the images. So batches are just going to contain like collections of the images, right? Choose a validation split, exactly. Very important. So this is what I was talking about earlier. You are not going to have a well-trained model if you do not validate in general. Okay, you really want to have some for training and some for validation. Okay, so for example, at the very end, you're going to want a couple of data, so like let's say 10% or 20% of your data, whatever. You want it to be specifically to determine if your training will work on completely fresh data, okay? So it's going to use these 80%, it's going to train with over and over and over again a certain amount of time until I understand decently well what's a tulip, what's a daisy, whatever. The 20% is for specifically fresh data. Okay, now that you've trained, how well can you actually perform on completely fresh data? That's what the validation set is for. Very important. Okay. So we found this many to the 5 classes, and we're going to use that many for training, right? Cool. Like if you guys want to see exactly what each line does, you can go over that later. I only have 8 minutes left, so I'm trying to get through the high level stuff as much as I can. Yada yada class names. That's right. Okay, cool. So now we're actually going to use matplotlib to visualize some of our data, right? So very plainly, with this figure size, for images and labels, right? So for for images and labels, right? So this will be the because we're using never mind. Sorry. We're gonna have the images and the labels, and we're gonna have a for loop that is going to process them, right? For I in range, you're simply going to get the plot of it, show the image, and then show the title of what's the label of it, right? And that's it. So this is labeled data, right? Because it's in the training data set, we want it to be labeled so that the model understands, oh, was that right or wrong? Okay, that's gonna affect my so I need to change that to optimize my loss function, right? Yada 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 yada. Yeah, like I said, I already sent it. I believe I already sent this to you guys, so you guys can just read over some of this later. Let's see. All right, we're gonna actually get into the creation of the model right now. Okay, so you're gonna have your neural network layers. Okay. You're going to compile your model, and okay, so let's see. Is this what I want? Yeah. Here we have a sequential model. Some of the parameters. Some of the models for our model. We can just see kind of like an explanation of what's going on with the model to a certain degree, right? We can't see every detail, but we can see some details. All right, here's the actual training part. Okay, this template is very common for when you're training stuff in TensorFlow, and even I believe even in Pytorch as well, right? So epoch just means, okay, we're going to train through all of the data. In this case, if we have 10 total epochs, then we're going to train the data overall 10 times, right? So that 80% is going to be trained at 10 total times, right? It shows you the loss function, the accuracy, etc., and the change, okay, between each epoch of training, right? So as you see first, in the very first example, our loss function is very high. We want it to be as low as possible. We want to have as little loss as possible. We want it to be as close to 0 as possible, okay? Your accuracy and our accuracy increases with each iteration, okay? So yeah, as you guys can see, the accuracy increases, and the loss value sorry, here's loss value decreases. Okay, pretty simple. All right, we're going to create some plots real quick. Let's see. So yeah, So let me see, what were these again for? Exactly. Okay, so yeah. So here we just determine what our actual training accuracy is versus our validation accuracy. As you can see, so specifically on the left, it's the accuracy, right? So the training accuracy increases with time. The validation accuracy remains relatively stable, right? So here the training loss, in other words, how close we are to what we want through the loss function is decreasing with time, and the validation is increasing with time. Cool. The validation loss. So they're off by a large margin. Okay, you want to overall create them. You want them to be closer. Okay, we have a problem with overfitting in this case. Okay, this is a sign of overfitting specifically. Okay, so how do we do that? How do we change that? We want to have when you have, so like overfitting can happen with specifically a small number of training examples. The more, if you give too much training of the same kind of issue can also appear. Okay, you want to avoid that as much as possible. So here we're just going to be going through some more data pre-processing and to make sure that our data is good data. If you guys want to look into good data, that's actually a very hard question to answer, because yeah, it's just a hard question to answer. Like even Andrew Ng has a problem with what good data is, right? There's literally a specialization of like science where you can specify what is good data in specific examples, right? You can look into it on your own time. In general, in these examples, you want to have data that is easily understood by the model, and it's what you want the model to understand. Okay. You want it to be clearly labeled, and you want to make sure that you don't have overfitting. If you can avoid those, if you can implement those things, you have decent enough data. Okay. So here are some augmented examples. So here all we did was simply change the orientation of the flower to try to optimize the loss function a little bit and to prevent some overfitting. Okay. Here we're recompiling, right? So we're running the training after having changed it a little bit. Okay. And as you guys noticed, we actually have a little let me see actually. Yeah, so we have actually worse values, right? So we want to change it again. Sorry, no, we have better values. My mistake. We actually have better values in this training, naturally, because we changed the orientation of the images. That actually ended up being better for our training because it was able to classify the right thing even with different orientations. So we added, we created better data in general. Okay. As you can see, our accuracies and our losses are actually now more closely aligned. So we've actually avoided overfitting. Okay. Well, we've actually corrected the overfitting a little bit. Okay. Predictions on new data. And that's it. That's the end. So at the very end, here we have our final score, right? Which is using obviously a Keras function. This image most likely belongs to sunflower with 99.10% confidence. That's the statistical confidence of our model. So we finally trained it to be really good. Cool. That's the workshop, guys. I hope you guys got some valuable information from how neural networks work, some of the deeper basics. So again, you want to have, for machine learning and deep learning, you want to have these high level steps very clear. You want to have good data. You want to make sure you pre-process that data really well. You want to make sure you have the right model for the job. Discrete data, continuous data are some things. You want to make sure that your model can actually process the type of data you're feeding it, etc. And you want to make sure that you have the output that you want. Okay. I know I probably overwhelmed you guys a little bit. That's okay. This is not easy stuff, but it's really interesting stuff, right? This is all cutting edge. The field is changing constantly. And yeah, you guys can learn whatever you put your mind to. I'm gonna send you guys some really good resources real quick because I believe that was the last slide. Cool. So this is just a really good article for sorry, this is specifically a domain in the website Medium for data science and for machine learning, AI stuff in general. Really great place to learn from people who will explain stuff in like normal human language, not with not with extremely complex terminology generally. Okay. Cool. I did upload so this is specifically using Google Colab, so it's just a website. I can just send it to you and you can just run this stuff using Google's resources. You don't even have to use your own machine. Cool. I'll send it. I just sent it again. Let's see. And also send this stuff real quick. So the Kaggle. So Kaggle is it's like leak code for machine learning and data science. Okay, there's competitions here all the time, and in these competitions, you are going to be given the data. You're going to be given a huge amount of data, and you're expected to kind of do something with that data, right? So you're expected to, like, for example, a competition that I remember was one with where you were given a bunch of X-ray scans, okay, and you had to create a model that was able to detect the cancer on those X-ray scans, and like the size of it, and if it's actually cancer or not, etc. Right? So that competition, the grand prize, I believe, was like $500,000, period. And you got to like have a relationship with the creators of the challenge and everything. Like, it was really crazy. Right. Thank you for. Oh, Yusuf already left. I'm so sad he didn't even say goodbye. So sad. But yeah, so let's see. So Kaggle's like the leak code. XGBoost, very important. I'm gonna say that real quick. XGBoost is one of the most popular models today. I would highly recommend learning it. Like, after you learn some of the basics, look into what XG models look like and how they work. It stands for extreme gradient boosting. Very, very good stuff. And this is probably my favorite book on deep learning, by Ian Goodfellow, who is a industry leader in deep learning. He's crazy. He worked at Google, and he's currently the director of artificial intelligence and machine learning at Apple. Really, really smart guy. Really good book. I'm sending that to you guys right now. What I really like about the book is that it goes over a lot of the foundational stuff you need mathematically in order to truly understand what's going on. Let me send you guys here real quick. Okay, so no problem. Hope to see you guys again in the future as well. Thank you guys so much for coming. I really appreciate it. Great science again, and the Amazon link. Thank you, Kim. Really appreciate it. Wow, thank you so much, Dylan. I really appreciate that. I tried kind of like blasting you guys with as much high-level information as I possibly could, because the details you're gonna have to learn on your own. That's more the math stuff, and the functions and stuff if you already know how to do programming. But yeah, thank you guys so much for coming. I really appreciate it. You guys can message me on Discord if you guys after the weekend, please, because I'm also hacking with you guys, believe it or not. So just message me anytime after the workshop. Connect with me on LinkedIn. Blah blah blah. I'm so happy. I'm happy to help you guys as much as I can with your machine learning and AI journey. I'm also an assistant researcher here at FIU. So yeah, if you guys can probably see me on campus every so often. Take it easy, guys. No problem, guys. Take it easy. Take it easy. Thank you so much. Thank you so much. Cool. Have a good one, guys. Good luck on your AI journey in ShellHacks. I wish everybody the best. Besitos. No problem, guys. All right. Good luck. Ciao, guys.